Welcome to the Innovation Hub of the Heriot-Watt campus in Dubai, and welcome to be a design engineer for a day. So why am I in the Innovation Hub? Well, this task is all about design. It is about innovation. It is about what engineering is all about. It's about creating innovative solutions for problems. So we're here in the Innovation Hub because it's where perhaps problems, creativity, and innovation all come together with engineering to develop those solutions. And one of the tasks that design engineers have is not just to design for a solution, but also to design for manufacture. And we have to be really aware of whether we're designing one for manufacture of two, for manufacture of 1,000, 10,000, or 1,000,000. And that will really influence how we design things. So I'm joined by Mohammed here, and we're going to go through some of the different manufacturing processes that engineers employ all the time that bring their designs and make them a reality. So Mohammed, we're going to start with 3D printing. Mostly when we think about rapid prototyping, how do we quickly make a prototype, we think about 3D printing. And of course, that's part of our Innovation Hub here. So maybe you could describe to me what exactly a 3D printer is.
Yeah, we sometimes also refer to it as additive manufacturing, which is basically we have a layer and then adding a layer on top of a layer and so on. So what is it doing right now is using this roll of plastic, and this could be a variety of materials. There are different printers to use different materials. In this case, heating it up to melt down and then have it follow a specific path that's based on the design that was initially developed on maybe a CAD environment, a computer-aided design, or the similar.
And that's a little bit of today's task. We're going to be designing in a virtual environment. You're going to be designing on a computer. You're going to create your design, and then somehow you're going to translate that design to some sort of mechanism, some sort of device, manufacturing device that's going to manufacture it for you. This is an example of additive layer manufacture, where we increase layer upon layer till we make something that, well, examples might be something like this. This wasn't necessarily designed, certainly not designed by an engineer. No. This is a CT scan of a pelvis. And we were able to then take that and translate it to a machine like this, and in successive layers, layer it up until this appeared. Now, we call it rapid prototyping. Wow. But something like this, Mohammed, how long does it take to manufacture?
Well, this probably took 20 to 25 hours, so it's not that rapid in a sense, but...
But I suppose in terms of a prototype, 20 to 25 hours can be considered rapid.
Yes.
For manufacture, if I needed to make one of these, that's okay. If I needed to make 100 of these or 1,000 of these, that's not very rapid.
Yeah, so you probably look for an approach that you can develop copies or duplicates at the same time, and then different processes such as injection molding and the same are very useful here. But certainly at prototyping or a one-off manufacture for very low production rate, and we can see sometimes nowadays with supercars, where you have 4 cars in a year, you probably go this route.
Okay. So one of the common threads of today's task will be about designing not just for function, but designing for manufacture. And there's so many other elements that we'll take into that. We will look at the sustainability, the use and effective and efficient use of materials. Sure. We're looking at the economic viability of something. And in a way, time is money. So the quicker you can manufacture something, the more economically viable that product or that solution will be. So let's move on now. We'll look at some of the other, and there's quite a few different manufacturing processes that we have here. I think you're going to take us through the vacuum forming down that end of the Innovation Hub.
Yeah. So we got plenty of tools here, and the task is really to have everyone who wants to use this space develop ideas quickly to make proof of concepts and prototype. One of the examples is vacuum forming. We do have 2 different units. Here is one of them. And what it basically does is use a sheet of plastic that comes at different thickness and clarity based on the application, heat it up, and then have it form on top of an object. So you can think about the 3D printed object and use it as an item here and make a form, or anything that's available in reality or anything else. Here, for example, we do have this unit, which is more of a mobile holder. And you can quickly, and this takes much shorter time compared to 3D printing, probably a minute or so. You make a copy, but then you'll think, oh, maybe not this. You can also create packages for items you have. I don't know. Do you like chocolate? Next time, think about how the package or anything really else that is going to form a car body, for example, lightweight. I'm talking about RC cars here in this case, and the same. Something else we do in the Innovation Hub is printing circuit boards from scratch in a rapid way as well. So let's check this out on the other side of the Innovation Hub with Taig.
So I'm over here and I have my little template. This is just a little board, a little bit of plastic really. And it is, however, the foundation or the fundamentals of part of any electronic devices, whether it's your mobile phone or any piece of kit, your computer that you have that involves some sort of electronics. Here in an Innovation Hub, we're able to very quickly create something that would look like this. This one says, "Hello World." And we're able to print on this surface the circuitry and then superimpose the electronics on top of that for it to do a function. So this one, quite easily, I can add my power supply to it and we can see it operate. So again, it's about taking concept into reality and doing so in quite a quick and efficient way. So you're able to quickly put your innovative electronics into whatever device or innovation that you are trying to manufacture.
True. And this could be ideal for prototyping, making 1, 2, 3, 5, and so on, to prove a concept and get it developed further, get it ready for manufacture using mass production operations.
Absolutely. And one of the benefits of this is instead of dealing with lots and lots of wires, you can make it in a much more compact form, which is generally how electronics are going these days. Smaller and smaller, more compact, more energy efficient, and more energy dense. Okay, so we can take you now through away from the Innovation Hub and into our fabrication lab, where we're going to show you some of the other techniques for manufacture. One of those is going to be injection molding. We'll see you there. So many plastic objects are injection molded. I'll explain what that is first before we then maybe give some examples. What we do is we take, well, some beads of plastic. This is the raw material. And we put it into a hopper in here. Now this heats it up. This heats it up and essentially melts it at about, well, in excess of 200 degrees Celsius. So you can imagine inside this hopper, you have this molten plastic. Now in the bottom here, we're able to put in a mold, something that looks a little bit like this. And it is essentially, the concave or the shape that we want to achieve. We put that mold together, and you can see it has a single injection site, what we'd call an injection site. And we clamp it in here in the bottom of our injection molding. So now we have our hot molten raw material and we have our mold. We clamp it up and we push this down, effectively extruding and injecting that hot molten plastic into the mold. And then when we open it up, we should have, well, one that I prepared earlier, our simple plastic product once it has cooled down. Now, that can be a really, really effective way of manufacturing not just one, but multiple. Essentially, you put your effort into creating this mold. So this is where we'd use subtractive manufacture. We start with the solid, in this case it's aluminium, and you shape it out. You take away whatever you need to create the volume, to create the shape that you're trying to manufacture. And then after that, it means rapid production, rapid cycling of this, creating multiple products can actually be quite quick, a little bit quicker than what you'd say 3D printing.
True, much faster, and you can think of multiple molds used at the same time as well, depends on what you want to achieve. Looking on the unit we have in here, it may sounds like manual, and again here we are targeting lower quantities.
Sure.
What is also good in here, we can do some very specific geometries using the 3D printer as a mold, and then have it squeezed within the clamp and generate parts which could also blend to other parts. For example, think of a bolt and you just want a handle to it.
Sure.
Things like that.
So the difference here, of course, is that you're putting your time investment. Your investment in your time is happening once. It's happening in the development of the mold, whereas the actual manufacture, the reproduction rate is actually quite high.
True.
little bit flipped for the 3D printing.
Yes, absolutely.
Excellent. So that again is just one other example of what we would consider a manufacturing process, and one that you would consider when you're developing different products. And of course, like you were saying, this is more a demonstrator level. These can be at much higher temperatures, much larger scales, depending on what you're trying to achieve.
Absolutely.
Okay, so let's take us over to, well, what will be today's task. You're going to design something in 2 dimensions, and you're going to cut it out or etch it on our laser cutter. So maybe we'll give a little bit of a demonstration of what a laser cutter can do, and then it'll be on to today's task.
Okay, so moving to our laser cutter in here. And there are a variety of laser cutters based on the laser power and so on. I'll tell you how this makes a difference. It's basically a computer-controlled machine that has a laser source somewhere at the back, and then use a set of mirrors to get the laser to where it should be focused right at the point where we cut it. So for example, if you imagine we have got this piece here, a perfect square with a hole in the middle. This is, in this case, we are using acrylic, so it goes into a behavior of plastic, and you can see we can also heat it up and bend it to do, for example, a box or something similar. But laser cutter can cut many other materials as well. There are laser cutters which can cut metals and so on. So a quick intro to the operation here. It all depends on the laser power and the laser movement. So if you imagine you have high power or high intensity of laser that moves really slow, that's going to perform cuts. While if you have laser that moves really rapidly, and then that will be more of etching the material or engraving. And here I got a sort of a partially completed unit that we'll get to see how it goes very quickly here. So if we go into operation, you can see this kind of operation here, slow movement with high power, and the machine is performing cuts and cutting all the way through the plastic material. While other operations will involve etching, which will be very much faster than this one here. Just like that. Now, while you are going to work with the task shortly, you need to think about what sort of speed and power you need to set for this operation. And we'll probably move to the task now and then meet you right after the demo to see more of the manufacturing.
Moving to the task details now, we are going to use the cloud-based editor found at vector.com. So get into this address, and this should be the page you see. If this is your first visit here, you are going to be required to register for a free account. So you should see sign up in here. Click on that and complete using your email address to get to use the online version of the editor. So click on use online, and this is what we are going to do at this stage, which is starting with a new artwork. So new artwork, and we could go with the print and select A4 size. The size doesn't really matter because we are interested in the design. However, it's good to start with something that's standard, so A4 is good. And we are going to go ahead and create a new artwork. This is now our drawing canvas, and we'll start adding the design. I'm going to develop 2 designs here just to give you an idea what you could do, but the possibilities are really endless. I'm aiming to make a key fob in this case, or a small hanging pendant. So I'm going to start with a circle, and ultimately I want to go with an oval shape. So I have selected the shape, and now I use my mouse pointer to click and hold to move on. I will adjust the size a little bit, but I can also enter the dimensions there, and I will be doing that. First, I will unlock the aspect ratio because I want different values for width and height. For width, I'm going to go with 80 millimeter, and I have just typed this using my keyboard. For height, I'll go with 30. So this is the base of the key fob that I'm aiming to design, and I can just click on it and move it wherever I want. I can hold Control on the keyboard and use the scroll to zoom in and out, and I can also do the same thing here using the View Control, zoom in and out. Scrolling is also going to move things around. Now that looks like a good base, but I'll need to refine it a little bit. I'm interested on having only the outer parameter. That is going to be the border where the laser is going to follow and cut. So I'm going to change the border here. First, I will enable the border and will change its color to maybe black. I will change its size to something that we can see easily. So 0.5 millimeter is something we can use. I don't want a color internally, so we could either select white here, for example, or you can type it in the hexadecimal, or you can just move here around the pointer, but ensure you are getting this value, or select white from there. This looks like a good parameter to follow. I just need a hole if I want to hang this somewhere. So let's go and introduce another circle. And this circle automatically came in the white color that I have just selected. So before I lose it, because it's white on a white paper, let's go and enable the border and set it to maybe 0.5, and now it is visible. While this circle is still selected, or I can even select it back, let me change the size now to 5 width and 5 height, and all these dimensions are in millimeters. Cool, well this is a hole, but it's not really in where I want it to be. Now I can use the alignment tool. I will click and hold and move my mouse pointer to select everything on the canvas. Or I can also use Control A, Control plus the letter A on the keyboard to select all. If I want to get out of the selection, just hit Escape on the keyboard. So Control plus the letter A, and now I do have some options related to alignment in here. I'll just show you. For example, if I align to the center vertically, the circle now in the center, I want it really to align in the middle horizontally, and then maybe to the side, because I want a hole. Well, this looks good, but the problem is if the laser cuts on the black line, I will end up with a gap there at that joining point. So I'll select that smaller circle, and I'll use my keyboard arrows to move it around, let's say 4 positions. If you go more in depth with this platform, you will be able to set even your X and Y positions. Now we got the hole sorted. It's time to add your design. Text is something you probably want to make use of by using your initials, your name, or whatever you want. I'm going to write engineer for a day here. And we can always work out with the scale and work out how this is going to appear in our key fob. As with normal engineering, design is based on existing designs. So engineers and designers spend hours and days and months developing very complicated designs, and you can just build on top of that rather than making a start from scratch. So here we can import files or images, but let's start by getting one. Our next stop is going to be this website, Open Clip Art. So let's say a car. Now the important bit is the image you want to import is going to be silhouette format, and that's basically something you can scale it in and out without having pixels involved. So let me use this one. You can see there's a large selection. There are multiple pages, and you can search anything you want. I'm going to go with this. I want to download the SVG or a vector file. So you can right-click, save link as, and I'm going to save it here in this folder. As you can see, I have already downloaded a couple. Let's download this in, and that's already there. Get back to the design, and it's time to upload that image. This is the one I have just downloaded, and I'm going to open it there. Okay, cool. I'm just going to scale this a bit to be like that. Again, if it's fully solid, just like this is likely to end up by, depends of course on the laser cutter setting, this might end up with engraving the full area. Or you could have an outline of this. So the same way, we are going to add a border, we add the color, and then remove the color from the car itself. And we could end up with the car outline in this case, or any other shape you select. While we are here and almost done, I would like to show you another option to do this. So I'm going to use the same image, but this time I'm going to use the image as or the car as outline for my key fob. And again, it's not a must use the car, it could be anything. I'm going to lock here the aspect ratio and the dimensions, and I'll set the width to 80 millimeters. Very similar to the key fob outer oval shape of 80. Now I want a border here, no color there, and I'm going to use this outline as a cutout. I'll need a circle just like that, so I could go and make a new one of 5 by 5. It's going to end up white, so let me add a border for it. That's black, and then let's adjust the size to 5. And now I'll select, probably I'll keep it in the middle of the wheel there. It will match the design, or even here. And this is where I'm going to hang my key fob or this pendant. I can use a text as well. I'm going to copy, and I have just done a Control-C to copy and Control-V in the keyboard to copy this. And I'm placing the text right there. You can use the alignment tool. You can even use the pencil or the pen tools to draw your outline or draw the details of your design. And that's really it. Time to share it with us. So you can do that by exporting, and we want to download the file in SVG. Something else which you can also do, and it's going to be really useful, is to share this file using a link that you can get it from a setting. This is the snapping, grid and snapping, to show you the grid and make life easier sometimes with drawing. From setting, you can get this link, and this can be shared with others to work on the same design, or share it with us as you complete your task as a proof of completion, and also for us to access it, download it, and manufacture it if your design is selected to be manufactured. That should be it with the task. Feel free to push the limits and come up with your very unique design. Play around with the software and show us what you can end up with.
Okay, so you've now made your design and you've done that in a drawing package. We'd consider that CAD, a computer-aided design. And then you took one step forward and you defined the toolpath. You essentially said what lines on your drawing are going to be cut, so high-powered laser at a slow speed, and what lines or etches on your drawing are going to be, well, scratched in or etched into that surface or engraved. And that would be a laser moving much faster and perhaps at lower intensity. So going from the drawing to the instructions, those computer-aided manufacture instructions, those then get uploaded to our laser cutter here. Now, we had a quick demonstration of this before. I'm going to ask Mohammed to complete it now and just set go on that. So after we've uploaded our drawings, it's doing a bit of etching, it's doing a bit of cutting, and it's moving around here according to the guidance that you designed of your design. And it's moving along as we go. So now it's moving a little bit slower, as we can see.
Yeah, it's probably the last cut.
Yeah, so the slower really means that it's focusing this high power laser onto the acrylic, which means it's cutting the whole way through. And it's just about doing the fourth side of our design. And that beep, just like your microwave, means that it's done. So I should just be able to pull this out.
Cool.
And it's going to fall for me.
Yes.
And it fell. I'll dip in and see if I can get it. Always a chore. And we get our design. So something that went from a concept in somebody's head to drawing, that computer-aided drawing, to then instructions that computer-aided manufacture to our device, then eventually becomes reality. Now, we'd do a little bit of post-processing on this, I guess. We'd clean it up a bit and it would make it look a little bit nicer, and then it ends up looking a little bit like this, Mohammed.
Yeah, so this is basically a multi-tool, and then we'll see what you come up with your design. We are looking forward to check them out and even manufacture some of them. So, to the task.
So I'm going to leave you with a couple of thoughts. Design for engineers is about taking those concepts and making them a reality. Really good engineering won't just design for one singular solution. It will also design for manufacture. If you're cognizant, if you're aware of how things are going to be manufactured, you can have better designs. Ones that are cheaper to manufacture, ones that are more sustainable and use less materials. And overall, coming up with more creative and innovative designs that will be the solution that you were originally looking for. Thank you again for participating as an engineer, a design engineer for today, and we look forward to having you engage with future events.